Chapter 2 is something like we are going to recall back about the different level of testing which you already know. Okay, where we, as what we have discussed in our chapter 1, we need to start our testing as early as possible from the small pieces until it become a complete system. So we cannot just do the testing after the entire system has been completed, all the units, all the modules has been integrated, where it will be too complex for us to start a testing. Okay, so that's why it's always given importance that uh, software testing need to be start from small, from early stage. So that is what we are going to discuss during the level of testing here. Okay, so as you guys all know, whenever we say that we are going to do dynamic testing on a code, so we always start with the unit level, which is the smallest level. So when we say individual unit, it means it's referring to individual functionalities. So for example, the most common one, we have this CRUD. So create is one function, retrieve is one function, update is one function, delete is one function. So this is actually individual unit. So when development team, they started to do the coding, they are involving in the preparing the source code, so they will be the one start with the unit testing. So as what we have discussed, white box testing will be conducted on the development side, then it will be followed with the black box testing. So when we don't have the complete system yet, but we already have the little functions one by one individually, so we can start to do the white box testing. So as a development team who is doing the code, they will be the one start to do the unit test. So they will be dealing with the source code, analyzing the source code, executing the source code to see if the source code work accordingly to provide the output. So that is where we will start the first level of the testing, where we will start. Okay, then when we said we are going to integrate, so normally when we said integration, okay, integration can happen in different levels. Okay, so it can happen when we are integrating functionalities become a module, it is still called integration. And also when multiple modules will be integrated as a subsystem or as a complete system, it is integration. Okay, so here what we are going to discuss is when a module contain the individual units being integrated to become at system level. So we start from the unit, individual function inside the module, then it will be integrated, then this module will be integrated become a subsystem in case if there is subsystem, or it will be integrated become the complete system. Then after that, the system can be integrated with the third party system. For example, we are having our e-commerce, newly developed e-commerce, and this e-commerce need to be functioning with other system. For example, online banking, with the debit card side, credit card side, touch and go side. So it means the e-commerce system need to be integrated with other systems. Other than that, the integration can happen on hardwares, on other softwares. So integration can be something continuously happen. Okay, so here we are going to discuss about the integration between modules to become a system. Okay, so we will discuss these two approaches, which is incremental and non-incremental approach. So it means how we are going to combine, or how we are going to integrate the module and we do the testing. Okay, So incremental approach where the modules will be combined, okay, to be tested, and it will be combined with the previously tested module. Okay, so later I will show you the diagram. So let's assume we have five different module in a system. So how we are going to test them? So we will be combining module by module with the every time with the previously tested module, then we will test them together. Okay, this is generally about incremental approach. While on the other side we have non-incremental approach where all the five modules, okay, same situation, all the five modules will be tested individually, independently, without being combined. So let's assume I have module A until E. So each of these module will be tested individually, A individually, B until E. Then we will combine all these five as a whole system. Then we test. Okay, so there is different approaches here. Okay, so let's see how they work. Let's start with the incremental first. Okay, so the diagram is actually showing the hierarchy of the modules of a system. Okay, so we have module A on the first one, and then the second level is B, C, and D, and then we have the third level, which is E and F. Okay, so when we set incremental approach, okay, so we actually test a module and then we will combine with the previously tested module. Okay, so later I will discuss about this driver and also stop later. Okay, so every time when we want to test using incremental approach, we always have a strategy which we can choose to use. Okay, either we want to test from from top to down, or from bottom to up. I think you have discussed this during your software engineering before. Okay, let's see how this strategy works. Okay, this one. So we have two different strategy which we can use. Either we want to use top down strategy. It means I start from the top level, okay, the highest level of the hierarchy, and then I move down to the last one. Okay, and the second strategy is bottom up. So it means I will start the integration from the lowest level of the hierarchy, and then I will move higher level. Okay, so something like this. Okay, so let's assume this is a hierarchy of a software. Okay, so A is the highest one, and then J, K, L is the lowest level. So we have four different levels here. So when we set top to down, it means we start from the first highest level, which is this A, or we can say it as a main module, move down to the sub modules until the last terminal module. Okay, so that is top to down. Okay, and the second strategy, bottom up, it means we start from the lowest level modules, or we call as some terminal modules, and then we move higher. Okay, clear about these strategies, how the top down and bottom up work? Clear, everyone? Please do let me know if there is anything you are not clear with. Okay, so when we set incremental approach, okay, we always need to decide how we are going to do the combining activity. Are we going to start from top module and then move down, combining them, or we want to choose the second strategy where we start from the bottom level module and then keep combining them until the highest level. Okay, so in your programming before, I believe you have discussed about drivers. you have discussed about stop? Any idea about what is this driver? What is this stop in programming? Anyone? Driver, stop. Have you heard this before? Have you used it before? It's in programming. Maybe have you heard dummy code? We need dummy code for testing purpose. Have you guys used that? Please, do let me know. Do respond me. I don't want to be talking alone, please. Have you guys heard about dummy code just for testing purpose? No. Okay. So actually, this is more onto coding, coding side. Okay. So we will use this stub and driver when we are doing integration. So it means while this development is carrying, okay, because we do integration while we are doing the development of the module, development of the functionalities. So when we want to do the integration and to proceed with the testing, okay, if there is needed of code where we have not complete the coding yet, so we might need to use dummy code. Okay, so when we want to use this dummy code, especially in this incremental approach, we need to decide either we need driver or we need stub. Both of this keyword, okay, if you see stub, okay, and also driver, both of this, they are actually referring to dummy code, but the terms being used here is actually indicated based on when we will use it. So that's why there is two different naming here. So when we are using top to down strategy, it means I start with the main module and I move down to the lowest level. So if I need to use any dummy code during the integration, I will use start. So it means I have started or I have my main module completed, but my lower level module is still in a process. So while I'm doing this integration, I need this dummy code to replace it for the testing purpose. So when we use a dummy code in the top-down strategy, we call it as a stub. So this stub will be replacing the lower level module to be called by the main module. Okay. So on the opposite side, when we do the bottom up strategy, it means we already completed the bottom part. So this strategy based on where we have completed and where we can start the testing. Okay. So when it comes to bottom up, it means we have done the lowest level module. So we will start from there. So whenever we need a dummy code, okay, to be replacing the higher level module to test the lower level module, we will use the driver. So this driver will be replacing higher level module, then it will be used to call the lower level module. Okay, so when we use these approaches to do the integration, we might need this dummy code in case the coding is not completed. Okay, but if the coding is completed, then we might not need this dummy code. Okay, so both of this driver and stuff, they are dummy code, but it's just that the level where we are using, the situation where we are using them differentiate with the terms. Okay, so this is about the strategy. So when we set incremental approach, okay, so just now we talk about the incremental approach. So we always need to decide either we are going to start from top. It means start from module A and move down to E and F, or we want to use bottom up strategy where we start from the E and F and then going up to the main module. So this strategy based on the completion of the programming or the development. Okay, so the example which given here is where we start from the lowest. So you can see we start from the E, C and F first. Okay, so this is actually the lowest level for this branch, for this what we call like this is one branch, this one, right? So C is the lowest level here. So E, C and F is actually will be tested first. Then after that followed by where B and E will be combined. So when I want to test my module B, I will combine it with E. And when I want to test my module D, I will combine with the previously tested F. Okay. Then lastly, all this will be combined when we want to test the module A. So this is using bottom up approach, bottom up strategy. So if it's top down, then we will start with the A, then we will combine B, C, and D with the A, and then we will combine the E, we will combine the F. Okay, so since here the example using bottom up strategy, so we will be using the driver. So it means whenever there is a dummy code needed, we will use the driver because we need this dummy code to replace the higher level module so that it can call the lower level module. Okay, got it? Clear? So if we are using the top down strategy, then we might need the stub to replace the lower level module to be called by the higher level module. So driver will be calling the lower level module functions while stub is actually being called by the higher level module. Okay. So that is about incremental approach. Okay. Then back to the non-incremental approach. So when we set non-incremental, there is no combining of module happen. It means like how non-incremental combining level by level, there is no combination happen in that way. So for non-incremental approach, what will happen is each of this module will be tested independently. It means one by one will be tested individually. Okay, so whenever we want to test this module individually based on the hierarchy, we need to have dummy code also to be replacing the higher level module and also the lower level module for that testing purpose. So compared to incremental approach, non-incremental approach will need driver and also stub. Both of it will be needed. So for example, I want to test module E. So since the E is the lowest one, I might need a driver to call these E functionalities for me to test. So let's assume I'm testing by module B. Module B is actually in the middle of A and also E. So in that case, for me to do the testing, I need a driver which will be act as a module A, and I need a stub which will act as a module E for me to do the testing for the module A. So compared to incremental approach. When we have a strategy to follow, non-incremental, there is no strategy because each of this module will be tested individually, then all these module will be combined and test as a whole system. That is the difference between incremental approach and non-incremental approach. Got it? Clear? Can understand the difference? So incremental means we are combining small sizes first and then make it bigger, bigger, bigger until the whole system. That is incremental. Okay, like incremental model. Okay, but when we said non-incremental, there is no small sizing combining happen. So we test them individually, then we put them all together as a whole system and we test them as a system. So that is the main difference of incremental approach and non-incremental approach. Okay. So another big difference is the usage of the dummy code during the testing. Okay. So this is about the driver and stuff. So both of them is actually dummy code, but it's just that the purpose when we are using them is actually at different level. So that's why we have a different naming here. Okay. So driver and stop used to replace the missing software and simulate the interface between the software component in a simple manner. So we need them for testing purpose in case if there is any missing software code happen. If no means we will not need. So as part of our testing criteria, test entry criteria, we need to check this. In case if we want to do integration testing, we need to check if the development of the code has been completed or not. So if it's not completed, then we need to generate the dummy code. So that can be part of the test entry criteria which we need to check. Not only documentation, not only test cases. So whenever we do different type of testing, then our test criteria also will be different. Okay, so this is just an example. Okay, so when we will use the driver, when we will use the stopper. So it's a simple component. So we have component A, we have component B. So if you see we have done or we have completed component A, then we need stop. And if we have completed component B, we need driver. Okay, so A is actually calculate the total marks. So calculate total marks is actually higher level than calculate marks for individual particular subject. So B is lower level, A is higher level. So I need this lower level marks first, then only I can do the total calculation. Okay, so the scenario one, when we have finished B, so it means we have completed the component B, where we able to calculate the marks for each individual subject. Okay, but we don't we did not complete the code for the component A yet. So I want to test if it's working accordingly or not. So we create a dummy code which is the driver to call this uh, component B, because I need to do the testing. I need to integrate them. So I cannot wait until the code will be completed. So I use the dummy code to integrate and test. Okay. So the second scenario, the same thing, but we have completed the component A. It means the functionality to calculate total marks has been completed, but the calculation to calculate individual course or individual subject marks is not completed. So what we do, we use the stop. it means a dummy code at the lower level, so that the module, the component A can call the stub. Okay, so driver, it as sorry, at the higher level will be calling the code. Okay, will be calling the lower level code, while stub is actually at the lower level and will be called by the higher level module. Okay, so that is the difference of this dummy code where we use them. Okay, so they actually being used at the different level. So one is having the higher level where it will call the lower level code, while stub is at the lower level, so it cannot call, but it will be called by the higher level modules. So that is the difference between stub and driver and when we will use them. Okay, so any question so far about the incremental, non-incremental approach, the two strategy, top down and bottom up, and then the two dummy code, which is the driver and the stub. Clear? Everyone okay? So far so good? Okay, that's great. Okay, so this is about V model. Okay, so as how we have other software development model, so we also have this V model. Okay, so this V model is actually giving importance on software testing. It means testing activity. Okay, so if you still remember yesterday during the tutorial, we have discussed about doing the testing at each stages in the software development life cycle. Okay, so the same thing goes when it comes to V model. Okay, but it gives importance on what we produce at a certain level to be used to prepare for the testing later. Okay, so this V model is actually stand for verification and validation model. So it will do verification at each level, and also it will do the validation later. Okay, so if you see, we have the analysis stage, we have the design stage, and also we have the coding stage. So what we prepare at each of these stages, actually what we needed for our different level of testing later. Okay, so if you see, when we have a requirement which we have gathered, which we have documented, so this requirement will be used to develop the acceptance test later. Remember, yesterday we were talking of how we are actually going to confirm on the requirement. So during the acceptance testing, when the end user conduct the acceptance testing, they will check if it's correct according to the requirement which we have documented. Okay, then the design documentation or the design which we have created will be used to develop the integration system test. So it means based on our architecture, what we have choose, how we are going to integrate the system, which module integrate which with which module. So all this is actually the system design. So what we produce during the system design, it means our design document will be referred to prepare for our integration. So it means to confirm if the integration has been correctly done or not. Okay, then during the coding, so it means we have the source code, we have the functionalities, we have the modules what we develop, right? So this will be used for component tests or to conduct the unit test. So V model is really giving importance to make sure the verification and the validation is correctly done in every stages throughout the life cycle. Okay, so that's why we are having the unit level, then we integrate become module level, then the module will be integrated become the system, and then this system need to be integrated, and then it will be followed by at the client side. Okay, so the next thing is, let's recall back what can be the advantages and the disadvantages of this incremental and non-incremental approach, because both of them, they have their own style how the integration will be done, how the testing will be conducted. So we want to do a little comparison to see the advantages and the disadvantages of these approaches, and to decide which will be a better approach to use. Okay, so the first one, okay, if you see, just now we have talked about using this driver and stop. Okay, when we need to use this driver, when to use the stop. Okay, so for non-incremental approach, okay, they actually required more works. This is because in non-incremental approach, each of these module will be tested individually. So in that case, when we use non-incremental approach, we will need driver, and also we will need stop. Okay, so this number is actually based on the diagram just now. So we will need both of them. We will need driver and we will need the stop. So in that case, if the more the coding is not being completed, the more we are going to create the dummy code to act as a driver, to call the lower level code, and to replace as sorry, to be the stop, which is replacing the lower level to be called by the higher level module. So for non-incremental approach, we need both of them. Okay, but for incremental approach, what will happen is we only need the driver or the stop. Okay, because when it comes to incremental approach, we have a strategy to choose. Either we want to use top down or we want to use bottom up. So in that case, I will only need either one. If I use top down, start from the main module to the lower level module, which one I will need, driver or the stop? If I choose top down strategy, I start from the main module, move lower level, which one I will need, driver or the stop? The stop, because we have completed the higher level, so we need the stop to replace the missing code at the lower level. So when it comes to bottom up, it means we have completed the lower level and we might need a dummy code to replace the higher level, so that this driver can call the lower level. So when we use incremental approach, we use the strategy either one. So we will only need driver or the stop. We don't need them both. So in that case, compared to non-incremental approach, it will require less work to prepare this dummy code. So which one is having the advantages here? Incremental or non-incremental? Which one is having the which one is having the advantage here? Incremental or non-incremental for this first point? Because we are discussing the advantage and the disadvantage, right? So which one is having the advantage here? Incremental, because we will require less work. Okay, so The second point, programming errors. For example, like any mismatch of the interface or any incorrect things happen during the integration of the module can be detected earlier in the incremental approach. This is because the module will be integrated with the next module much more earlier compared to non-incremental where each of these module they will not see each other until we combine them as a whole system. So when we already integrate them as a whole system, the complexity is actually there and it is considered very late. So whatever simple programming errors will be giving us big headache in non-incremental approach. So programming errors which can be detected earlier. It means one module with another module. We can already detect them. So when I combine these two modules with another module, I can detect them. But when it comes to non-incremental approach, all the five modules will be tested individually. Then I combine all these five together. So when there is programming errors happen, it is very complex for us to do the debugging later also. Okay, so due to this point, debugging activity is actually easier in incremental approach compared to non-incremental approach because in incremental approach when we able to detect the programming errors earlier in a small size of integration between two modules between three modules not as a complete system yet, so the debugging process can be much more easier to be done. But in non-incremental approach, we will only detect them after they have been combined as a whole system. So the debugging will be much more complicated. Okay, so in that case, point two, point three, who is having the advantage? Incremental approach or non-incremental approach? Is it identifying the defect is better in an early stage or not? Yes, should be, right? Because we can identify it earlier, we can fix it easier. Okay, we might not spending a lot of resources, a lot of time, a lot of money there. Okay, so the advantages for point two and three will be incremental. Okay, let's see the next point. Actual modules receive more exposure by the completion of the last module task in incremental approach. So if you see in incremental approach, each of these module have go through more testing compared to non-incremental. So if you see incremental approach, every time the module has been integrated with another module, it will be tested again and again. So the first started module will be tested multiple times until we combine with the last module of the hierarchy. So in that case, the module is having a better quality when it go through many round of testing. But in another side, for the non-incremental approach, what happened? How many times each module will be tested? How many times each module will be tested in non-incremental approach? Lesser means how many times? Can we know the exact time or not? How many times each module being tested in non-incremental approach? Are you sure we don't know? I thought we know. Are you guys sure that we don't know? Yes, only two times, because each of these module will be tested individually. So one time. So after done with the individual testing, we will combine it as a whole system and we will test for the second time. So for non-incremental approach, each of the module is actually tested only two times, as an individual module, as a system. So of course it is lesser compared to incremental approach, but we have a fixed number there compared to incremental approach. So the quality of the non-incremental approach might be lesser than the incremental approach. Okay, so the advantages for this point is going to the incremental approach also. Okay, the next point is machine time to execute is lesser for non-incremental approach. So it means since each of these module being tested only two times, okay, so the machine time which is used to do the test execution is lesser in non-incremental approach, while it will be more in incremental approach, because every module go through testing many times again and again. So the machine time used for test execution in incremental approach will be more. Got it? Okay. But the machine time actually can be used for two purposes. One is for the test execution. One is for generating the stop and drivers. Remember? Just now we talked about it in the first point. So, since in our first point we already know non-incremental will be needing both of them. So what will happen is the machine time which is used to generate the stop and driver will be more in the non-incremental approach compared to incremental approach, because in incremental approach we will decide either we need driver or we need stop, because we don't need both of them. So machine time which is used to generate this stop or the driver will be less in incremental approach. Can understand? So machine time has two different usage here, and for each of this usage, each of this approach, they have their own advantages. So machine time used for test execution is less in non-incremental approach, but the machine time used to execute this driver and stop, it will be more for non-incremental approach. So for the incremental approach, it will be on the opposite side, because the test execution is more, so the machine time used is more. But the dummy code which is needed in incremental approach is less, either driver or the stop. So the machine time used to generate them also less. So there is one advantage point for incremental and one advantage point for non-incremental. Okay, then the next point is non-incremental approach can enable parallel testing activities, since each of these module will be tested individually, so we can test them parallelly, because we don't need to wait for them for any reason. So when it comes to incremental approach, okay, since incremental approach, we need to combine this module. So we cannot do parallel testing activity, because we need to wait for one module to be tested first, then it can be combined. So until then, that particular module cannot be tested. Yeah. So for point 6, the advantage is for non-incremental approach because it can allow the parallel testing activity compared to incremental approach. Okay, got it? Can I understand? Okay, so that is the 6 points where we do the comparison between this approach and we able to know which approach is having the advantage. Now we want to finalize which approach is better. So in the summary, from the point 1 until point 4, the advantages was actually for incremental approach. Okay, you can check back what was the 4 points. Okay, then while the point 5 and point 6 actually disadvantages for the incremental approach because non-incremental approach has the advantages. Okay, so let's see if this advantage and the disadvantage is really matter and which one is having a better advantages. Okay, so in the current computing industry, okay, compared to years back, okay, hardware cost actually dropped. Okay, like my time before, pen drive is very expensive. Now it's very cheap. Okay, so hardware cost has been decreasing. Okay, so whatever advantages we discuss on the hardware side is actually not a big advantages anymore because we are not spending a lot of money on this hardware part. Okay, so the when the hardware cost has been decreasing, hardware capability actually increase. Okay, it means the sizing, how it can support the storage, all these. So hardware capability increase and labor cost. The people we need, okay, labor costs and the consequences of software errors are increasing. Okay, so when we able to identify errors defect earlier, okay, then it can actually lower the cost for the debugging, the cost for the repairing part. So in that case, through the point 1 to 4, okay, are growing importance compared to the point 5. Point 5 just now is the machine time. So this machine time advantages is really not playing very important advantage anymore. Okay, because usage of the machine time is not really a big amount of money anymore. Okay, because we will be spending money more on other things, which is like the labor cost to do the testing, to do the debugging. So in that case, point 5 becoming less important. And when it comes to the advantage of point 6 just now, which is enable the parallel activity, it's not really a big disadvantage for the incremental approach. Okay, so in that case, incremental approach is having better advantages compared to non-incremental approach. So if we have a choice to make to use any one of this approach, then incremental approach will have better advantages. So it become a better approach to use. But let's assume if we have no choice, we must conduct using non-incremental, then we can use it. Okay. So for example, for your assignment, Okay, because your assignment, you need to mention about this approach in your strategy later. Okay, so if you see the system which you are going to select for your assignment, are you the one developing it? Are we going to do the integration before we do the testing here for your assignment? Have you guys selected the system? So, is it your system? Are you the one developing the system? Is it the programming part still not complete? Or the system is already integrated? So, you need to understand. So, the system which you are going to use for your assignment purpose, it's not a developing system. It's not currently being integrating, but it is already integrated, and it is actually working as a system. So in that case, you need to know which approach or which strategy will be suitable to be used here. Got it? Can understand? So when you are explaining later, okay, you must not talk about stuff. You must not talk about drivers, because there is no missing code in the system you are going to test. So everything is completed, and you must not mention like you need this, you need to generate this driver, you need to generate the stuff when you are doing integration and so on. Okay, so please make sure you clearly understand how to discuss about this strategy later. Okay, got it? Clear? So you, for your assignment, you are preparing test plan. You are not preparing assignment report or coming up with stories. So there is no assumption in test plan. What you see, what you plan, what you are going to do, you will put directly, exactly, that is the test plan. So this is not like other courses assignment where you assume it can work like this, you assume it will be like this. No, there is no assumption. What you will do, what the system let you to do, that is what you are going to mention in your test plan. Got it? So it is very important for you to be clear about how to prepare test plan. So there is no lying, there is no anything which is not real in your testing later. Okay, so don't come up with any stories. Okay, got it? So clear about all this. So I have discussed the top down, bottom up strategy. Okay, this is just the example how each of the strategy work. So when it comes to top down, so we start from the A, and then we combine them with B, C, and D. Then we combine with the lowest level, which is E, F, and G. Okay, and when we use bottom up, so we start from the lowest one, which is the E, F, and G. Then we will be combining where E and F with the B, and then we have the C, and then we have the G combining with the D, and then we will be combining with the A. Okay, so that is about the bottom up and also the top down strategy. Okay, so this will be the advantages for each of the strategies. We have the advantages and the disadvantage for each of them. So in a overall way, okay, we will choose to use which strategy based on the completion of the code. Okay, so it means when I have completed by my main module, so I can start from top. But if I did not do my main module yet, because some project they like to do in that way, where they do all the lowest level functionality, the input output functionality first, then the last thing they will have their main module. So it's depend. So in that case, if we have completed the lowest level module, then we will choose the bottom up strategy. So the advantages of this more strategy is where we have completed and we can able to find the flaws or to find the defect from that level. So if we use top down strategy, the advantages will be when the major flow happens towards the top of the program. So it means the code what we have done on the top, if it's giving us the error, sorry, the defects there, then it will be an advantage. So the same thing goes when it comes to bottom up, when the major flows happen at the bottom of the program or the software. Okay, so once the input output functions are added, it means the lowest terminal level of functionality has been added, then the test case will be easier to be represented. Okay, then since main module is always the backbone of the program, okay, so it will allow us to know exactly how strong is the is the software, so it can allow us to do the demonstration of the overall software. Okay, so let's see the advantages of the bottom up first. So the same thing, the bottom up, the advantages is when the flaws happen at the bottom part. So since we already have the input output function, so the test conditions will be easier to create. Okay, and we can also do the observation of the test result easier because we already have the functionalities, then we can already know what is the condition is going to do and what will be the test result. So this will be advantages of the bottom up strategy. So let's see the disadvantages of the top down strategy. So what will happen is, of course, if the code is not being completed, so for top down we must produce the stub. Okay, so because we need to replace the lower level code so that we can use the main module to call that. Okay, so it will be much more complicated than it will appear first. Then before the input output function added, so the test case which is using the stub can be a bit difficult to be represented. Okay, then the test conditions may be impossible and we might not able to identify the correct test output or result yet because we don't have the actual code, but with the stub maybe the correctness will not be as much. Okay, then for the disadvantages of the bottom up, so what will happen is we need to have the driver, so we need to produce the driver if there is any missing code happen. So until the driver, sorry, the main module is there, okay, the entity of the entire program or the backbone of the entire program does not exist. So it will be a bit difficult to control the program. Okay, so that will be the advantages and the disadvantages of both of the strategy. Okay, clear? Clear with this incremental approach, non-incremental approach, stop, driver, and then top down and the bottom up strategy. Can everyone? Any questions so far? Any question?
No question.
Okay, great. Okay, so it's okay, right? I can continue, right? So the next part will be the higher order.
Miss, I have a weird idea, but I want to ask, is it
Yes,
possible to combine both bottom-up and top-down strategy to make something like a sandwich strategy or something like
yes,
that?
yes, can.
Oh,
So it's actually not something fixed. This strategy, even to choose the bottom up or top down, It's something that depend on how the development is going on. So when you want to combine them based on how the development has been carried, yes, you can use the sandwich approach, the strategy.
Interesting.
Mm-mm.
So, but if I were to suggest something like this as an answer in the final exam, would it be acceptable or?
Let's assume if because our syllabus here we did not cover about combining both of them, because our incremental approach we talk about either one of these. So I prefer not to have the sandwich strategy. But let's assume if the question is like your own opinion, something like you can justify with your own logical answer, yes, you can use it.
Okay, thank you, Miss.
Mm. So it's always like that. If any question, it is like a close question where you can see they give you the way how you suppose should answer. It means you must choose this one or this one. So in that case, your answer must be either one of it. Okay, but let's assume if it's an open-ended question, something like, okay, based on your own understanding, okay, which approach is better, which one you plan to use for this given scenario, then you can talk about both of them in this way, and maybe if in any situation you want to combine them, you can. So please read the question and try to get the idea what exactly the question try to cover. Okay. Okay, so let's move to the next part. So we have talked about unit level, module level, and then we do the integration, become a system. So here where we will start with the higher order testing. So higher order testing means after we have integrated, now we have the system. So we call it as a higher order testing, where we want to test them as a complete system. So let's go through this flow, okay, where it's actually start from the end user, and then the end user give the requirement, and then from the requirement we have the projects or the software's objective, and then the external specification. From the specification we have the system design, and from the design we have the structure design, internal program structure design, and then the interfaces specification, and then the code. So if you see, each of these artifacts which we are producing will be used for different level of testing. So for example, we have module testing, and then we have integration testing from the system design, the program structure design. Then we have the functional testing from the requirement or the specification. Then the system testing will be indicating if we have achieved the objective or not. And then the acceptance testing is to confirm all the requirement has been fulfilled or not. And also we have the installation test. So this is actually moving towards to the client side. Okay, so we are going to see some examples of higher order testing. So it means as an integrated system, what are the type of testing which we will be discussing, which will be needed to be conducted. So the most famous one is the functional testing. So this is more to black box testing, no more white box testing. So when we have integrated as a system, we have the user interface. It's come out from the development department to the testing department, so it will be moved towards to the black box technique. So here when we said functional testing, all what we want to try to see is if the system is actually function according to the specification or to the external specification given by the client, how the system actually behaves, the behavior of the system from the end user point. So we want to see if there is any issues, there is any gap happen. in the functionality according to the specification. So we do the functional testing. Okay, then we have the system testing, where the system testing is nothing about the external specification but the system's objective. Okay, so it means we want to see if the system fulfill the objective or not. So we are trying to compare the whole system to its objective, to the original objective, what the system supposed should do. Okay, so we will be having the objective and then we try to test them according to that objective. Okay, so this will be different types of system testing. So I have total of 15 categories, and we will see back some of it in our chapter 3 later also. Yeah, chapter 3 later. Okay, so here we will go through one by one. So this is actually like a table format in a simple format. So each of these slide actually talking about them again and again. So if you prefer to have a short version of the description, so you can use this table format. Okay, so we will start from the facility testing. Okay, so facility testing, it's something like redundant with this functional testing too. Okay, so we want to see if each of the functions, okay, able to work accordingly or not. Maybe some companies they use different term. Okay, so facility testing or function testing actually is kind of similar. So we have a checklist to see if each of the function is been doing what it's supposed should do or not. Okay. So volume testing. So I believe you have heard that before. So when we are dealing with volume of data, okay, so we need to conduct this volume test to check if the system able to handle heavy volume of data or not. So when the data keep on growing bigger and bigger, the more the system is in the usage. Okay, so the more data it's going to be stored. So the volume of data will be keep on growing bigger. So this can actually disturb the system's performance and also the objective of the system. So in that case, we will conduct this volume testing to test how is the capability of the system to handle high volume of data. So volume means it's all about data only. Okay. So the next one is the stress testing. Okay. So stress testing here is we want to see how the system able to handle the stress given to the system. Okay, so it can be heavy workload. Okay, so it means when there is many transactions happen frequently. Okay, or maybe at a particular time. Okay, like a peak time, so there is something like suddenly come up, so there is a heavy load going on. So can the system handle that stress? Okay, so volume of data also can be a stress for a system. Okay, so when we generally say it as a stress testing, volume of data can be part of the sets. Okay, but when it comes to volume testing, it's only about the data, nothing else is part of it. Okay, so other than that, any unusual activities or maybe huge number of devices accessing, like huge number of user, I think like when you guys trying to register for co-curriculum, suddenly student intranet like gone, cannot use. When you will start to do the registration for your elective courses, so we used to have this problem of, so this means that the system did not able to handle certain stress. Okay, so we need to confirm that if the system able to handle this or not. So this can be different types of stress. Okay, so this is just an example between the volume and the stress testing if you confuse. So volume testing means could the typist cope of a draft of large report, sorry, of a large report. Okay, so here we talk about the amount, large amount of report. Okay, but when it comes to stress testing, could the typist type at a rate of 50 words per minute? So now we actually have a stress given here, so there is a rate of stress given to the typist. So in a minute, can they type this amount of word or not? So it means we are stressing them within that short period of time. This big of thing must be done. Okay, so that will be the difference between the volume test and the stress test. Okay, then we have usability test. I believe everyone know about the usability of the system, how important it is. So the system user interface is very important when we talk about working in a real environment later, because the end user must be comfortable, okay, to use the user interface. They must understand how is the flow of the user interface, so it must be usable enough for them able to use the system within a short period of time. Okay, then we have security testing, where it is all about the security objective. So we want to see how maybe like any unexpected access or any attacks or any penetration can be happen to steal data. So we have to concern about the security. So there will be security testing conducted to search where will be there is, if there is any security holes. Okay, then we have performance testing. So this is very important. As a higher order testing, we need to confirm how the system able to perform. Sometimes the functionality all is perfectly working, but the performance is not. So your client will be still not satisfied with that. So we need to focus on the performance or the efficiency of the system. So how long is the response time whenever there is any request being given to the system? How fast the system can respond? So how within this time of period or not? Okay, so if there is high workload given, how is the response time? Is it affecting the response time? So we need to know the performance. Okay, then we have storage testing. So storage testing is more on storage of a system, where the amount of the system have the storage to handle the daily transaction, the memory of the program. Because when the data is keep on growing, when the transaction is keep on growing, when the users access is keep on growing, it can be affecting the storage. So how well we are managing the storage, like temporary files, log files, and then how the files being arranged. So all this can be affecting the performance later. So storage is a very important thing which we need to test. We need to ensure that the system has a proper amount of memory or storage for it to run without any issue. Okay, especially without any delay happen. Okay, then we have configuration testing. So configuration normally like involvement of hardware, software, or any special tools, devices. So a proper configuration must be tested. So can the system work together with this multiple softwares, with this multiple operating system, with these hardwares from different brands, different specification. So we need to do the configuration test to confirm that. So especially like if you are coming up with a web application, okay, we have multiple web browsers in the market. You cannot limit your web application to be functioning only in one web browser, because you cannot force what your user will be using. So you have to make sure that you are developing something which can be working equally in different platform, different web browsers, different operating system. So you need to make sure the configuration first. Okay, then we have compatibility testing or conversion testing. So compatibility is another one which is very important. This can be based on softwares, also based on operating system, also if it's compatible to function or not. So we want to see how is the compatibility when there is any changes happen, when there is something new has been installed, or if we are using a new version of database, the upgrading of database. So how is the compatibility happen? Okay, then installation testing. So installation testing based on procedures, based on user manuals. Okay, you must test if the installation part has been correctly documented, can be done correctly or not. Okay, so because let's assume you are the one developing. So let's assume when it come to client side, when you are doing the installation, you know what to do. Okay, but when it come to passing it to your client side for any purpose, their IT department, they need to know. So you have to make sure that the installation of the system is also need to be tested, to make sure that the process, the procedures of the installation has been prepared accordingly. So this can be involved the documentation of user manual or system manual, and also the step by step how the installation should be done. Okay, then we have reliability testing. So reliability testing is all about how well the system can be functioning, how will be the downtime of the system whenever there is any issues, for example any software issue, any hardware or network issue. How long is the downtime of the system? So that can actually indicate the reliability of the system, how fast it can be up again. So we need to conduct the reliability testing to confirm the reliability level of the system. Okay, then reliability is also somehow related with the recovery. So recovery testing here means we want to test to confirm if the system able to recover by itself or not. Because if you see sometimes when you walk into mall, right, there is screens inside the mall, and the screen is showing like a error page, error message, and like nothing happened until someone realize it and they do fixing. So it means the system did not have the recoverability. Okay, so here we are focusing on the recovery level of the system. So whenever there is any errors, any failures, any issues, can the system able to recover by itself or not? If the system will be remain down until someone need to go and fix it. So when the system has a low recovery level, it will be affecting the reliability of the system, because the more longer time it takes for recovering, automatically the downtime of the system will be more, because it cannot up immediately. Okay, so we have to do the recovery testing to test if the functionality is able to recover and proceed to work or not. Okay, then the next one is the serviceability or the maintenance testing. So this one we are trying to see how is the system service during the operation, how will be the maintenance characteristic towards the system later in the future. So after our clients started to use, so how well the system is going on at their operation environment. So what are the type of service, what are the maintenance we need to provide to them. Okay, then we have documentation testing. So this is more to the documentation, to check every documentation is accurately has been prepared, and it must be upgrading every time when there is changes or upgrading happen on the system. So documentation and the system must be tally. Okay, then procedure testing. So normally procedure is more to certain people who has certain roles. Okay, for example, the system administrator, database administrator, the person who is actually taking care of the system. So they will always have these procedures to follow. So this can be human procedures or it can be documentation procedures. So we have to make sure that this procedures has been prepared and it has been tested, so that these people who is taking care of the database, taking care of the system, able to have the document in case if there is any issues happen. So they should know how to do certain procedures. So this must be tested. So this can be the system, the people, and also the documentation involvement. Okay, then the next one is acceptance testing. So acceptance testing is part of the higher order testing, but acceptance testing is not only testers, it has nothing to do with the testers, but it is more to the end user. Okay, so for acceptance testing, we have two level of acceptance testing. One is alpha and one is beta. Okay, so towards the completion of the development. Okay, so maybe we have done like 97%, 98%, everything is going to be finalized soon. So we will be inviting the end user at the developer site with the supervision of the developers for them to test the system. Okay, so normally at the alpha stage, the actual end user can be invited, or sometimes internal people can also pretend like end user. So let's assume, okay, our company is too small, we cannot bring in people. Okay, what we will do is, other than the developers who was part of the development, other people who is not doing the coding, who is not involving with anything, who don't know anything about the system, we can invite them to pretend like the end user. Okay, and then for them to test, to do this acceptance testing at the alpha level. The reason why we are conducting this alpha test is for the developers to gather the feedback from the user, how they feel about the system, how is everything okay or not. So they still get the feedback from there, and from the feedback they will be doing changes. So it means changes still allowed to do here. So maybe they are not happy, like, oh, why the color is so bad like this, huh? This one suppose should be something else, so when they give the feedback, right, so they will be actually able to gather, and the developers will do the fixing. So that's why this is actually towards the completion of the software, still at the developer side. Okay, so developers gather the feedbacks and they will do the enhancement from there. So once we done at the alpha test, then we go to beta test. So at this beta test, it is like something we have enhanced from this level. So we believe everything is okay, no issue much. Okay, so this will be also called as a field testing. Okay, we will discuss about this in chapter 3 also later. Okay, beta testing also called as a field testing, because the system will be installed at the client side, at their actual working environment ready. So now there is no supervision of developers, no feedback gathering, all this no more. So it means we are already finalizing at the client side. So we install at their environment. Okay, so they will be testing the actual end user, the actual customer will be testing the system at their side. So this will be beta level. Can we still get complaint at the beta level? Can we still get feedback from the client at the beta level? Like just now we gather at the alpha level, am I right? And the developers do the changes according to that. So now at the beta level, when we already install at the client side, something like okay, everything is good, can we still get their feedback like something is still not okay? Can they still say it out? Do you think it will be 100% perfect, no issue at all? And if we get this feedback at the beta level, what we will do? What we will do? Why we call it beta? You always seen, right? Like system, they actually publish the system, they actually already passed the system, but still they put like beta version. What does that mean? Is it 100% completed, 100% convinced system? So it's something like the system is there, is working, everything is done, okay, but it is still as beta version because they can still do the changes, they can still accept the feedback, and they will still keep on updating it, but while the user is actually using the system. So this is more to maintenance side, while the user using it, and if there is any fixing needed, any changes needed, so they will still do. So that's why they will still call as a beta version. Okay, so here we try our level best before we move here. You get? So here we have the supervision done during the testing, but here we consider that everything is okay, we already get the feedback earlier, so you can start to use the system. So while you are using, if there is anything, then it will carry as the maintenance period. It means they will continue to do that, okay, until everything is okay, then they will say it is no more beta version. Okay, so even once you have installed at your client side, you cannot just say okay, I'm done, we are done, we have completed the project. No, software it's something like continuous things need to be done. So even after you're done with the development, they started to use, you will still need to provide them some service. So that is where the maintenance all will be happening. Okay, then actually it is kind of repeating with the installation testing. So this is not to find any software errors or any software defects, but this is actually to find during the installation process. So we are not trying to find any errors made or any defect inside the software, but it will be more during the installation. So that's why we need to test if the installation can be carried accordingly or not. So when it comes to at the client side, the installation must be done accordingly with their environment, with their database, with their hardware. So it is very important for us to confirm the installation. Okay. Then user interface testing is something related with the usability just now. So this is more to the human computer interaction, how the system is being developed, how easy to use, how it's actually helping in their daily task. Okay, so normally we can get a survey to be done, how is the user interface and how is the usability level of the user. Okay, then we have regression testing. So regression testing, in a short form, if I want to make it very clear for you, every time when there is changes happen in your source code, in your functionalities, in your any features, every time when there is changes happen on the software, we must conduct regression testing. Okay, immediately after every time changes happen, because when we set changes on the features, changes on the requirement, actually it will be changes on the code. So every time when there is changes on the code happen, even during the defect debugging, there will be changes happen. We need to conduct regression testing. So regression testing, something can be in any level, at the unit level, at the module level, integration level, but here we are referring to the system level. So every time when there is changes happen on the system code, the source code, okay, we need to conduct regression. So the reason of why we conduct this regression test is we want to monitor how is the side effect of the change, if the change bring a new defect or not, if the changes happen affect the behavior of the system or not. So every time when changes happen, the test case need to be updated to confirm that the new code is working fine. There is no new problem being created. So that is what we call regression testing. This regression testing is actually some people they call it as a retest, you know, repetition of the test, retest, right? Okay, but normally retest will be used uh, on repeating the test, even though there is no changes happen. But regression test is actually more to every time there is changes, we need to conduct the regression test. So retest and regression test is actually a bit different. Okay, so this is something we frequently do, regression testing. Okay, then we have the critical path testing, the last one. So this one we define the critical path or the main part, main function of a system. So we must do the testing. So the critical path must be tested first. Okay, so this is make sure the system will not be having any issues later, especially when we set this critical path or the main module or the main function, it work as a backbone of the development of the testing. So we have to make sure that this critical part is actually working first without any issue. Then we can proceed with other functionality, other type of testing. Okay, so normally critical part testing is more to like critical type of system, large system which can be affecting in many ways if something is wrong on this critical part or on this main function. Okay, so that is when we will conduct the critical part. Okay, so that's it for our chapter 2 about the level of testing. So I have covered the lowest level, start from the unit, module, and then system, which we call as a higher order level. Okay, any question? Any question? Everyone okay? Everyone clear? You actually have learned this, the levels and so on, but maybe something is still new. Okay, so we just try to recall back from your 2163 before, the basic about the testing before. Okay, any question? Everyone okay? Clear with the level of testing? Can I? Can understand? Huh? Okay, so if there is no question, nothing, then we are done here. So I have completed our chapter 1 and chapter 2 on the first week. Okay, so if nothing, then we can end the session here. So I will see you Monday. Okay, thank you very much, guys. Have a great weekend.